So discriminant analysis is a classification approach similar to logistic regression. Now the question is, why do we use it then? Well, it has few advantages over logistic regression. Let's see what are those advantages. Firstly, if you recall, we discussed in logistic regression that if there are more than two classes of the response, then we prefer other techniques over logistic regression. So discriminant analysis is a popular approach if we have more than two responses. Now if n is small and the distribution of the predictor x is approximately normal in each of the classes, then the discriminant model performs better than the logistic regression model. Also, when the classes are well separated, the parameter estimates for the logistic regression model are surprisingly unstable. Discriminant analysis does not suffer from this problem. So that is how it is. We don't have to go into the why of it. Basically, highly learned statisticians have done this for us already, and we just have to believe them and move on. Now that it is apparent that discriminant analysis has an edge over logistic regression, whether you understood it or not, it's a secondary thing. But that is a fact. So let's take it as it is and learn it now. So we have two types of discriminant analysis: linear discriminant analysis and quadratic discriminant analysis. Linear discriminant analysis is used when the variance-covariance matrix of all the classes is same or does not depend on the population from which the data are obtained. Now what does this mean? This was a bouncer straight above the head. So let's understand this with the help of a graph. So if you look at the graph, we have shown two classes, one with circle and the other one with triangles. By just looking at it, you can see that variance is consistent within the two classes. Hence, we can easily use a linear decision boundary here. Now let's look at the second figure. Here we can see the variance of the data within the two classes are not same or consistent. Here if we use a linear decision boundary, we will end up with a poor model, because a linear boundary will not be able to discriminate between the two classes. Thus, in such cases, we use a quadratic decision boundary. So that was the difference between LDA and QDA. Now obviously you cannot look at the data every time and tell if the variance-covariance matrix is same or not. So for this purpose, we use two tests called box-M test and Levine test. Now we don't have to go into the details of these tests. We will let the software do it. Just understand that these two tests are used to check if the variance-covariance matrix are equal or not. Also, LDA and QDA assumes that data is Gaussian. That is, it follows normal distribution.